Question 8, part A. So for part A, we need to show that sine x tan of x over 1 minus cosine of x is equivalent to 1 plus 1 over cosine of x, where x cannot be 2n pi, where n is an integer. So the way we can solve part A is by basically simplifying the left-hand side of this equation, which is this over here, and basically simplifying it as much as possible using our trigonometric identities until we can show that it is equivalent to 1 plus 1 over cosine of x, and hence that would be showing that the left hand side is equal to the right hand side. So the first step over here is basically multiplying the top and bottom of this fraction over here by the conjugate of the denominator. So the conjugate of 1 minus cosine of x is just 1 plus cosine of x. So if we multiply the top and bottom of this by 1 plus cosine of x, then we get sine x times tan of x, and basically if we expand this, we get sine of x tan of x plus sine of x tan of x times cosine of x, and then over here we get 1 times 1, that's just 1 times cosine of x, that's positive cosine of x, negative cosine of x times 1, that's negative cosine of x, and then negative cosine of x times cosine of x, that's just negative cosine squared of x. And then if we use our trigonometric identities over here, so we know that we can substitute tan of x with sine x over cosine of x. That's just a standard identity. And once again, we substitute that over here as well. And then the denominator, the cosine of x minus cosine of x, that just cancels out, which leaves us with this. And then if we continue simplifying, we notice that the cosine of x over here, that cancels out with this one, this cosine of x. And then sine of x times sine of x, that's sine squared of x. This sine of x times sine of x again, we get sine squared of x. This cancels out. Our denominator stays the same for now. So now we get sine squared of x over cosine of x plus sine squared of x. And then over here, I have used the Pythagorean identity. So basically, if I subtract both sides of this identity by cosine squared of theta, then I'm just isolating sine squared theta. So now I've just isolated, so then I just get sine squared of x over here. And now since we have a common denominator, I can separate these two parts basically. So I get sine squared of x over cosine of x divided by sine squared of x. And same over here, that's just, and then we get plus sine squared of x over sine squared of x. And then if we simplify it further, this whole fraction, that just becomes this, sine squared of x over sine squared of x, that just stays the same. And then we notice that sine squared of x over here, that cancels out. This stays the same. Simplifying it further, we get 1 over cosine of x over here, and then sine squared of x over sine squared of x, that's just 1. So by just working with the left hand side, we have shown that it is equivalent to the right hand side, and that's our answer for part A. Now for part B, it says, hence determine the range of values for k for which sine of x times tan of x over 1 minus cosine of x equals k. So it says that we need to use our result from part A, where it says hence, and then find the range of values of k for which this has no real solutions. So we can first of all rewrite this as 1 plus 1 over cosine of x equals k. And now over here we need to use our knowledge of the range of the graph of y equals cosine of x. So we know that the graph of y equals cosine of x, it doesn't satisfy the following conditions. Where -1, it cannot be greater than cosine of x, and cosine of x cannot be greater than 1. Because if we graph it, we know that the range is between -1 and 1. So the minimum is just -1, and the maximum is just, it's always 1. It can't be anything, so it can't exceed 1, or it can't be anything lesser than -1 either. So now what we can do is that if we can find an expression for cosine of x in terms of k, and then basically substitute that value or that expression into cosine of x over here, and then simplify our inequalities, then it would hence be showing, or hence be finding, a set of values of k for which this has no real solutions. So if we just work through this, we know that, so we got this, obviously. So if I subtract both sides of this equation by -1, I get 1 over cosine of x equals k minus 1. And then if I multiply both sides of this by cosine of x, and then divide both sides by k minus 1, I hence get cosine of x is equal to 1 over k minus 1. So now that we have found an expression for cosine of x in terms of k, we can substitute this into our inequalities. And then that would basically be finding a range of values for which this doesn't have any real solutions, because it just doesn't hold. So if you look at our case 1 over here, we know that -1, it can be greater than cosine of x, right? So if we can substitute 1 over k minus 1 into cosine of x over here, we get the following. And then if we multiply both sides of this inequality by k minus 1, we get negative k plus 1. And then since we're multiplying it by -1, the sign flips. So then we get negative k plus 1 is less than 1. And then if we isolate k, we just get that k is greater than 0. So that's one condition. So this is one of the range of values for k for which this will not have any real solutions. So we've done our workings for that. Now we need to do the same for our case 2, which is cosine of x is greater than 1. So if we substitute this expression over here, 1 over k minus 1, into this, we get, into cosine of x, we get 1 over k minus 1 is greater than 1. Multiplying both sides by k minus 1 gives us the following. And then if we isolate k in this inequality, we get that k is less than 2, and hence there are no real solutions for when k is between 0 and 2, and 0 and 2 are not included. So that's the basic idea for part B. Part B is a little tricky, but the main point is to use our knowledge of the trigonometric, or basically the range of cosine of x, and we know that it can't satisfy the following conditions as the range is set. It's between -1 and 1. So if we can just try and work through our expressions, and then if we can find an expression for cosine of x in terms of k, we're basically substituting it into our inequalities, simplifying it further, and then we know that this is our final answer. So thank you for watching, and let me know if you have any questions in the comment section below. Thank you.